Hi Bhaskar, hi Ravi, good morning.
Hi, Arun. Good morning.
Yeah, hi Bhaskar.
So finally, our batch is back. So all issues resolved now.
Yeah, right. Still two more classes.
Yeah, Arun, I will go through those videos. I didn't get time yet. I will go through that
Yeah,
later.
sure, Bhaskar. Yeah, please go through the videos. Yeah, like whatever sessions you have missed, right? Like past 2, 3 days, those recordings are already there. Yeah, and please let me know if you are facing any doubts.
Sure.
Today's class will be the most important
Hi,
topic right now. Yeah, hi Ravi.
hi, Arul. Good morning.
Good morning. So today's class will be the most important topic in the AI area. So let's wait for others also to join.
Yeah,
Okay,
sure,
so
Arul.
today's class is all about like retrieval augmented generation. So that is the trending topic right now in the market. Okay, let's wait for a few more minutes and
Yeah,
then
yes, Arul.
we will
Yesterday,
start it.
yesterday I saw a few mock interviews. On every interview, they are asking about RAG.
Yes,
Yeah.
right, Ravi, because this is the most needed one in the entire AI space. Because there are two ways to use our own data along with the LLM. Okay, one is
Okay.
to fine tune it. Mostly companies are not doing fine tuning nowadays because that requires lot of computation and that requires and also there might be chances that your data will be getting trained on the model, right? So to overcome that, actually, nowadays people are using only RAG. So everywhere, wherever you see any Gen AI project, those Gen AI projects are using only this retrieval augmented generation. That is RAG. This is a technique actually. Yeah, so it's not a procedure, like it's a technique. And nowadays this is evolving. Like day by day, it keeps on improvising. Like every time it is getting a new thing. Like yesterday when I was preparing this material, again I came to know few more techniques in drag. Yeah, likewise only it keeps on like you whenever you are doing something, then try to explore that in the real world how it is working out. Like this. Now already there is something called the graph rag also came into picture. Okay, so this is from Microsoft. Okay. Microsoft also released something 1 month back only. Okay, the same way recent track developments you can check.
Yeah.
See, there are a lot of people who are talking about rag, right? You can go through those videos as well. Okay, likewise, follow this rag alone. This rag alone is becoming a big area right now. And that too, in 2024, like within past 9 months, they are modifying rag like anything. So there is something called Llama Index rag. So there is something called the Llama Cloud Rag, and then Auto Rag is there. Likewise, a lot of things are coming in recent days. There is something called Llama Cloud. This also we will use on tomorrow's class we will see about Llama Index complete. Today's class we will see a bit about LangChain, and tomorrow's class is all about Llama Index. The Llama Index. Today's class itself we will cover this LangChain stuff, and tomorrow's class we will see about Llama Index, and we will build a RAG-based question answering system on Llama Index tomorrow. And then yeah, there are a lot of things happening in the open source world of AI, and Tomorrow's class, we will discuss about what are the next steps after these classes. Let's see who has joined. Yeah, hi Srini, hi Prashant, hi Sudhir. Good morning.
Hi, Arul, good morning.
Good morning, everyone.
Hi. Okay, let's start the class today and then let people join in between and then they can go through the recordings, right? So today's class is the most important topic as I told. So this is all about retrieval augmented generation. So up to yesterday's class, do you have any doubts? So that because here we will be talking more on this uh, AI related stuff only. So if we go through this, then I am thinking that at least you get some basic understanding on these four classes, whatever we have covered so far, 11, 12, 13, and 14. For the past four classes, we were talking about generative AI, right? So means that like at least you could have been able to understand what is a token, right? That is very, very important. And we talked about the numerical representation of a data, right? That one we saw on the ChatGPT stuff, like in platform.openai, right? We saw how the tokens are getting found, right? You remember?
Yes.
Yeah, certainly.
Found tokens on OpenAI. See, this is the tokenizer. There it is counting the number of tokens, right? So here, if we are giving something, see, it's getting changed into tokens, and these tokens are again, it is stored as token IDs, right? So this is 86007 represents this many, and this 4339 represents this words, right? Likewise, it will convert these tokens. These things and all we have discussed in the previous classes. So tokenization, how this is happening, and that depends on model to model as well. Okay, so in GPT 3.3, it is 64 tokens, and the recent GPTs, it is 57 tokens. Okay, from 64, it get reduced to 57. Okay, when model sizes got increased, this token also will reduce. Like means that depends to depend. See, quarter of a word it will convert. So 100 tokens is equal to 75 words. Okay, so this is how it works, and you can check it in here. So this is used to tokenize, like tick token is one package, so that you can able to understand how this tokenization is working. Okay, so this will simply break down your text into small chunks of tokens. Okay, so let's not go deeper into this. So this is all about tokenization. Why we are talking about tokenization is like our RAG, right? So this RAG also we will talk about tokens somewhere. And then we will talk about like today how to create embeddings and how what is a vector store, right? And then after that we will be doing a practical exercise with the RAG itself. Okay, up to day 14 class, any doubts, please let me know. Otherwise, we will jump into the class.
All good.
Yeah, thank you, Ravi. Then, yeah, today's class is, as I told you, this is nothing but it's retrieval augmented generation. This is a technique actually. This is an approach. Okay. So this is an approach in the sense like this is like a kind of a technique which will be used to work with our private data. Private data is in the sense what? Like that is company's data. Maybe your own data, right? There are a lot of possibilities, right? Your own data, company's data, right? So you, those things and all will not be was not been trained on the models itself. So whatever LLM you take, GPT 3.5, GPT 4o, as well as like our Gemini, right? Also Olama, Llama, these are a lot of stuff, right? So in these LLMs, your private data will not be present, right? Your private data will not be present in the sense, suppose take for an example, I am Arul Benjamin Chandru, right? So that Arul Benjamin Chandru's particular personal information will not be present in this LLMs, large language models, right? So in that sense, if you want an information about Arul Benjamin Chandru, how you will fetch it, right? So that is one thing. So basically, I'm just saying it for an example, but it's not advisable to store personal information in LLMs. I don't know, like whether they were already having some personal information getting stored on LLMs. That's a different story. We don't want to go deeper into that. There are something called safe AI, responsible AI for that companies needs to follow. Okay, so means that they should not include any personal sensitive information inside these LLMs when they are training when they are training the models. So by that time, in the data processing itself, data pre-processing itself, they need to clean up our personal sensitive informations. Likewise, only they need to feed the data to the models. Then only that model will not contain our personal information. So for an example only, I'm talking about like about Arul Benjamin Chandru, it won't know anything, right? And also the real world data, what's happening inside, right? That real world data also, these things will not, these language models will not know. See, even you can go to ChatGPT and ask it like, when was your last knowledge cutoff date? Means that that was the date. See, it is saying that it didn't know anything after September 2023, right? Up to September 2023, whatever information is present in the world, those world knowledge has been already fed into GPT. But after that, it's almost 1 year, right? So for the past 1 year, whatever happened on real world, those things and all ChatGPT don't know. But ChatGPT can use its search information, search retrieval options to get up that information. Suppose in case if I am asking like who is because recently Andhra had an election and that Andhra Pradesh chief minister got changed, right? So now it's not with Jagan anymore, and it's with Chandrababu Naidu, right? So
Yeah.
who is the chief minister of Andhra Pradesh? If I am asking, because this happened on last March and April, right? See? As of its knowledge, it's still showing that Chief Minister of Andhra Pradesh is Jagan Mohan, right? So this is how LLMs work, and because it didn't have this knowledge, okay, it didn't have the existing knowledge of it still had the existing knowledge up to this particular time, right? After that, it won't have the current relevant details, right? So for that particular purpose, okay, this RAG comes into picture. You can feed the recent information in the form of documents, right? But you are not going to train the complete model. What you are going to do is you are going to prompt it along with your document. Like if you are attaching here, right? This is not exactly RAG, but I will tell you. See, take for an example. Suppose in case if I am attaching a document like this, and if I am asking a question on top of that document, right? What it will do, it will simply search this document and it is giving me the response. Means that it is not going to train this. Okay, it is not going to train this inside this model. Okay, so my information will not be fed into the model for training. Okay, that's what these people are telling, but I am not sure like whether maybe they can train, right? So in that case, okay, there might be chances that you cannot completely expose your document, right? You need to specifically extract some information which are related to your query, right? And that needs to be sent to the models. Then only model can generate a readable text for you, right? Just for the linguistic understanding alone, what we are doing is we are coming up with a technique called retrieval augmented generation. Okay, suppose consider you are building a chatbot for your company. Okay, so that chatbot should be responding all the information which are related to your company related stuff. Take for an example, you all are working in insurance, right? Suppose you are having a claim information. Okay, you are having a claim information database. You should not expose that, but I am saying this for an example. Okay, suppose someone is coming and asking like what was the John's last claim. Likewise, if someone is asking, then how your chatbot will know that, how your model will know, like what was the last claim of John, right? So that will be stored in your company's personal data. So that data you cannot expose everything. So what you will do, you will build a RAG approach out of it. RAG approach is nothing but retrieval, augmented, and then generation. Okay, you need to split this into 3 particular segments. Okay, this complete RAG, this segment, this sentence itself. Okay, you need to split it into 3 steps. Okay, one is retrieval. Okay, retrieval means what? First, what it will do, it will go into the company database based on your query, right? What the user is asking? What is the recent claim for John? So it will simply go into your company database and it will search for the recent claims. And out of that, it will try to match John. So now it will fetch one record, right? It cannot simply show that one record to the user because user don't know how a select query looks like, right? He needs a formatted stuff. He needs a formatted answer. So that only it will be like a kind of a natural language conversation, right? That then only he can understand English. He don't know how an SQL looks like. You cannot say like return fetched one row from this particular table like this, right? So that he cannot understand what's exactly over there. So for that you need to augment the response. Okay, augment the response in the sense you need to take that response, okay, and along with that your query will be there. Okay, what is your query? Your question is like when is the last claim for John? Along with that, your query could have retrieved one entry from your table, right? So that one entry and this query, these two things we will be passing that into LLM. So now your prompt will be augmented with your original query along with the data which it is fetched from company stuff, right? So these two things only will go to the LLM. Correct? So now you are augmenting the prompt. So that's why it is called as augmented retrieval. First, you retrieve the data from the table and then you are augmenting that prompt. After that, you are passing that to LLM. Okay. So when your retrieved information is passed to the model, okay, what happens? Your model knows how to structure a language stuff, right? It will know that you are giving it a response, you are giving it a query response along with the prompt. So that what it will do, it will simply format that output and it will give back to the user saying that, hey, the last claim for John is rupees, or sorry, dollars 200, like this. Okay, so this is how that retrieval augmented generation works. Okay, so this is what is all about retrieval augmented generation. Whenever you are seeing a sentence in the AI area, first try to split what it is telling to you. Okay, just try to correlate with your existing English knowledge so that you can easily understand what exactly this is. That is the first thing. And then how this RAG is working. That's what we told, right? What it will do based on your user input, based on your user query, it will retrieve that information, right? After that, your retrieved information and your query alone, these two things. Now you have two things. So these things are augmented. So now your prompt will be augmented and that augmented prompt will be sent to this model. So now once your model receives both your query and then result, right? So it can generate a text out of it, right? So that's why they are calling it as create a coherent and a detailed response. So it will simply rewrite the entire story for you as in a human readable form. Okay, so also model don't have any current information, right? So if suppose in case, if I have the election results also, and then I can ask, if I am asking it like, who is the Chief Minister of Andhra Pradesh, along with the document, right? See, take for an example, if I have a Wikipedia article like this, right? See, now I have list of Chief Minister of Andhra Pradesh. Okay, so now I have this Wikipedia article. Okay, so I can just simply give this link to ChatGPT saying that refer this and let me know on who is the Chief Minister of Andhra Pradesh. Like this, if I am giving, and I am giving a source. This is the source, right? So with this source, it will search and it will let me know who is the current Chief Minister of Andhra Pradesh. See, now it is doing searching the web, right? Oh my God, it's giving me that. It's doing some nonsense. Why? Because it's doing that's that's having an in-memory issue. Okay, previously I was giving it one other link, and with that link, it is giving me a roadmap to study machine learning. So now I am studying machine learning. That's why it is giving me the roadmap, because previously I used. Or else what I can do, I can simply take out all this Wikipedia article. Yeah, or else I can simply take out this table alone. Can give the statistics alone. Or else I will give this statistics. Can simply take out the statistics. It's not going to be so quick. I'm just selecting all these statistics. Okay, so this is the data now. Right, I'm just taking out this data, and in ChatGPT I'm asking, as per the below table, who is the current Chief Minister of Andhra Pradesh? So now it is not going to train with this data. Okay, so now it knows, right? Now it knows the, oh my God, this is nonsense. It is still thinking like Jagan is the Chief Minister, right? But that is not the case. Actually, Nara Chandrababu Naidu is the Chief Minister, right? So if you are giving so the main purpose of this is like, if you are giving a table along with that to the LLM, right? So now LLM will have this data. Okay, when from what time he is becoming the Chief Minister, right? Maybe it might not know the 6th of September. Oh my God, this is nonsense, man. I didn't expect a result from this like that. Okay, so actually the main exercise of showing this is, okay, so if I am giving a table like this, okay, and then this table is having some data, and this table is representing that the current Chief Minister is Chandrababu Naidu. It's not Jagan Mohan Reddy, right? So now if my LLM knows this table, and I am sending this data along with my query, right? What my LLM will try to do, first it will search the query inside this table first, and then with that it will go back to ChatGPT. Based on that, it will restructure the response like this. Okay, so it will be updated based on the knowledge cutoff. Search the web like this. Just, see, now it's searching the web and it is giving me the answer, right? So what it is doing, it is searching the web and it is fetching this information. Along with that, it is pairing my query, right? And then it is reformatting the output, whatever it fetched off, right? So this is also RAG. Okay. So what it is doing, it is doing the retrieval from the website. And then it is augmenting this query along with the searched stuff. See, it searched on these four sites, right? With that searched stuff, now it contains this one and the search results. With that, it will again send back this to the GPT 3.5 or GPT-4o, right? So when it goes to GPT-4o, GPT-4o will restructure this and generate this answer. So this is the generation and combining your query and the searches. This is augmenting and first it will search the internet, right? So that is called as retrieval. Okay, so this is what is retrieval, augmented and generation is all about. When talking in plainer terms, it looks very simple, but this is a bit complicated stuff. Why? Because the text you are giving, right? This text can be understandable by LLM only when this is converted it into vectors. Vector means the numerical representation of the text bunch, whatever you are passing. Okay, then only it can do the construction of the words. So for that, what you need to do, your entire knowledge source, whatever your company data, that needs to be converted it into vectors. Okay, so that vector along with your search term vector, both the things it will go to LLM and LLM will try to format that vector into sentences likewise. Okay, so that is the underlying hood of RAG, and RAG have multiple varieties. Okay, so we are having something called Graph RAG by Microsoft. We are having some future prompting RAGs. We are having some minimalistic RAG, right? Lot of retrieval augmented generation approaches are evolving in the market. So what we are going to see is we are going to see a basic RAG. So our basic RAG will be used for retrieving the information whatever we need based on the data which we are passing. Okay, it's like a private search on our own repository. Okay, if you are building a chatbot, you need a RAG. If your company don't want to expose your complete company data into LLM, so the main purpose of RAG is you don't want to expose your company data or your private information completely to a model for training, so that if it is getting trained, then what will be the consequences? Now if I am asking, like, we saw an example, right? When was the last claim, sorry, what was the last claim for John? So it was saying some $30 or $40, right? So that should be internally within that company. And if it goes to that LLM, and if we are training LLM with that, what happens? Suppose tomorrow, if someone like if I am also I am not a company, I am not your company employee, right? I am not part of your company. So if I am coming and if I am downloading that LLM from the internet, then I can also access John's information, right? So then there will be a data leak. So to avoid that particular purposes, what company started to doing, hey, I don't want to train the complete model. What I need to do is I will build my own knowledge information as a vector by myself, okay, within the company itself. So what I will do whenever user searches for something, I will combine that with my searched results. Okay, and then I will send to the LLM only the particular result. Your LLM needs to take care of only formatting that result into a human readable form. Okay, so that is the only purpose you are going to serve me. Your machine learning model is going to serve me. Okay, for that you need to give me a best model out there in the market. That is the business demand right now. So businesses started to use this generative AI just because of this evolving RAG approaches. Because no company wants to fine tune their company data into these machine learning models. If they do that, then what happens? Then their data will be completely exposed to that model. And suppose if that model went out of that company server, then everything can be easily hackable, right? So the main purpose of each and every company is to protect their user base and protect their user data, also protect their private information. That's why companies started to use these RAG approaches. And also real-time data, real-time information, these models don't know. Whatever is happening in the current industry, it don't know. That's why it keeps on saying me, still the Chief Minister of Andhra Pradesh is Jagan Mohan Reddy, right? Recently, like last April, May only, the election happened, and Chandrababu Naidu sworn as a Chief Minister, right? Okay, so that real world information you don't know, right? So that's why we are using RAG. And what I asked again to with the ChatGPT, I asked it to search it from the web and prepare a augmented response for me. Okay, it augmented the prompt along with that retrieved information, and it generated a responses for me. That's why we are calling it as retrieval first, and then augmenting the prompt along with this response means that combining the retrieved response with the prompt with the original question, and then we are feeding it to the LLM and we are generating the output. Okay, so for that actually we have a lot of tools. Okay, you can go through these notes. I will share you these notes. Okay, these and all are the theory part. Let's see this in practice. Okay, just copy this link.
So still like even once the external source is readed, like it is the prompt is converting into answer. Like say I have given a prompt and that is having external source and
Yes,
it given the result, which means one time for the first time LLM is reading my external source.
yes, right, Sundar. Yeah,
So still it won't store because it won't be
still it
trained.
won't store because that is part of your prompt only. It won't store.
Okay.
That's why companies want to use their local LLMs. Like
Okay.
we saw yesterday, like Llama 3.1, right? Llama
Mhm.
3.1 is a local LLM. We were
Yeah.
seeing Hugging Face contains lot of models, right? That's
Mhm.
why company don't want to expose their data. That's why companies want to run their own LLMs on their machines.
Okay.
Okay, if they like in our today's example also, we will be using local LLM only. We are not going to expose our data to Gemini 3.5 or GPT 3.5, GPT 4o, right? So still companies have a fear that even these people might use their prompts to train their data like this.
Okay. So local LLM means see, somebody built that model. We are downloading into our local
Our
system and
local machine, and without internet also we can execute in our own machine. Yeah, right. So now I have shared this document, and yeah, these and all are the use cases of RAG. Okay, and in practical applications we saw about customer service, right? This is like a chatbot kind of, and then you can use this for research assistance. You can give some 20-30 research papers and ask it to summarize. That also it can do. And then you can get some personalized recommendations based on that what documents you are giving back, right? Same way you can build chatbots out of it. Okay, so this is the architecture we are talking about. Okay, so now in the AI space where the data engineering comes into picture, that's what most of the people are asking, right? So the data engineering thing comes into picture in this A and B area. Okay, so what they will do, they will be simply preparing data from multiple sources, and those data will be stored in the data lakes or data warehouses, right? So from there, this A and B, this is the data engineering area. Okay, you can think it of like that. From this, what the next parts will do, we will be simply taking out that entire sentences and we are chunking it into tokens. Token means 3/4 of a word or a word, right? So that depends on model to model. So based on that, we will be simply splitting that entire language corpus into small things. Okay. And then we will be storing that as a numerical representation. How we saw that tokens have a numerical representation, right? So those will be stored as a numerical representation. So this is the company's internal database. This vector database is there, right? So once you convert that into numerical representation, that will become embedding, and that embeddings will be stored in this vector database. Okay, so this vector database is your company's local database. Okay, and also when you are trying to do a question, when you are trying to give a prompt, okay, what happens? This prompt will be again converted into embedding, and that embedding will be searched on this vector database because this vector database is already having your company data, right? Up to this point. So this is having your company data. So in your company data, now you, after searching it, right, you will be having a response. So that response along with this question, we will be passing that alone to the LLM model. So that model will again augment this. So here we are augmenting this query and then this vector database response. And with that, we are feeding that augmented generation to this LLM. And LLM, that is our model. Our model will be converted that into a meaningful human readable response. So this is how RAG works. So this flowchart will give you a fair understanding on how a RAG works. Okay, so data preparation will be done by data engineering team. So they will be taking care of converting your tables, PDFs, text files, documents, or else spreadsheets, right? So whatever it is, even OCR, human readable form. So everything into a single data lake, like single data warehouse. So inside that, they will be having bunch of information. Okay, so that bunch of information, they after that this GenAI process starts. So this GenAI process, what it will do, we also use some models to chunk this data, chunk and embed this data. Embed means it will convert this into vector representation. Mathematical vectors are there, right? So it will simply convert this chunked data. Chunked data is the huge volume of data, the huge volume of sentences. It got split into chunks, like some 1,000 words, thousand characters, or 2,000 characters, or some 300 characters like this. It will simply split the data into small parts. And those chunked data, that will be again embedded, right? So that embedded values will be stored into this vector database. Okay, so this vector database is nothing but this is a numerical representation database. This is not our regular SQL database. Okay, so this stores mostly numbers and this stores in a vector format, mathematical vector format. Okay, so this database is completely different from our regular SQL databases. Okay, so what are all the vector databases? So those databases are, there is something called FICE. FICE is like Facebook AI similarity search. So that is one database. That database, you can use it locally in your own machine itself. And you can convert this, you can store all these embeddings into this FICE itself. That is one database. Same way, if you want to store it in a cloud, you can use Quadrant, QDRANT. Quadrant is also one such big vector database. Same way, we have something called PG vector, that is for Postgres vector database. So that will store it in Postgres server. So in Postgres server itself, you can have a this is not an SQL stuff. This is completely not an SQL stuff. This will contain vectors and retrieval from this. Don't use any select queries and all. Okay, it is not using any select query and all to retrieve the information which got stored here. because this is a numerical representation, right? This is not a tabular structure, right? So this numerical representation is in mathematical vectors. So in this, to retrieve this information, there is something called similarity search and then cosine similarity. Likewise, there are a lot of ranking mechanisms. That's a complete machine learning area. Okay. So based on your query, every database is having different ranking mechanisms, scoring and ranking mechanisms. According to the similarity matches, like whatever questions you are asking, related to that, some similarity matches will be there, right? So according to that similarity matches, it will prepare a bubble of words, I can say. It will prepare chunk of bunch of words which are already stored here, right? So now it will return me the words. Along with that, this query also got split into words. Now this words and this words, like this numerical representation and this numerical representation. So that will be again passed to an LLM. Again, LLM also stores all these tokens in a numerical representation, right? It will match everything and it will construct that as a sentence, and that sentences, that is a human readable form, that we will get it back as a response. So this is how the RAG process works. RAG is an approach, as I told you. Okay, any doubts in this, so that we can jump on to the code area for this.
So for AI and Gen AI, so we will not use our normal databases. So only
Yes, Ravi.
vector.
Yeah. So we will use our normal databases as a raw data source only.
Okay.
From that, again, you need to convert that into a vector database. With the vector database only, you can apply the RAG.
Okay, got it.
Yeah, Ravi. So this is mathematical vectors. Okay, so in that mathematical vectors, vector scalars we studied on 11th standard, 12th standard mathematics, right? So that vectors only, this is, so it stores this data in a numerical representation. Okay, so this is, so in the entire Gen AI area, they will be using this vector databases only, because LLMs also store the data in vectors. LLM can easily understand vectors. Okay, and there is something called re-ranking also in it. Ranking, re-ranking also will happen when you are passing that to vector database. This here, I told you, right? There are a lot of mechanisms. One is cosine similarity, one is similarity search, right? Based on that algorithms, it will simply try to fetch the words, and the words which it got fetched, right? So that has ranking also. It will fetch a word, it will fetch a numerical representation, and that numerical representation is having something called similarity score. In that according to that similarity score only, it determines whether that is really needed or what. Okay, and that needed information alone, it will pass it back to the LLM along with this query, with your query, so that it can simply get that data alone and it will process that. It will simply use this transformer alone. Instead of doing a search inside this entire corpus, it will simply use its transformer mechanism alone to format this data, and that data will be converted it into a human readable form. Okay. There are certain tools and technologies for building RAG systems. One such thing is vector database, as we see earlier, right? For vector databases, we have something called Pinecone. Okay, Pinecone also stores and searches the document embeddings. This also you can run locally, and also there is something called Facebook AI similarity search. This is FICE. Okay, so here this is the most efficient tool right now in the market. This is developed by Facebook. That's why it is called as Facebook AI similarity search, FICE. Okay, if I go to FICE, right? See, it is saying Facebook AI similarity search. This is from Meta. Okay, Meta gives us this library. Okay, FICE will be, you can install and use FICE in your own local machine. Anyway, we are going to do that. Okay, and then Llama, LLM integration. In LLM, like we have Olama's Llama, right? Yesterday we saw about Olama. Olama is also Metastream, right? Olama is, sorry, Olama is the open source language, open source model executor. Llama is the Facebook. Llama 3.0. Llama is like large language, meta something like this. It will come. Okay, so in this Llama, you can download and execute these models locally. Same way, you can use OpenAI's ChatGPT also as an API or Gemini AI also as an API with the embedded, with the, for generating the natural language response. Okay, you can use OpenAI's model also. Most probably people use OpenAI's GPT model only because that will be accurately augmenting the, sorry, that will be accurately generating the response based on your information what you are saying. Okay, there is for the document chunking. Okay, we mostly people use Apache Spark, PySpark. These and all are ETL tools, right? So using that, you can process huge number of data here. Okay, for our case, we will be using something called a sentence transformers. Okay, that sentence transformers, the name itself is telling that it will be simply converting that word, that sentence into small pieces. Okay, and then there are some models for converting this into numerical representation, the chunked data into a numerical representation. For that, we use this sentence BERT or OpenAI embedding API. Embedding is the correct word. Embedding means it is converting the what is that characters into a numerical representation, like okay, a vector representation. And then for that storage of these embeddings, right? We can use vector databases alone, or else you can use this PG vector also. PG vector is like you can store it in like, consider this PG vector as like a kind of a table or a database like this. Okay, there you can store and there you can retrieve your information whenever you want instead of storing this in folders. Okay, so FICE, what it will do, it will simply convert it and it will store it in the folder. So there itself you can apply similarity search. Okay, so these are all the RAGs use cases and solutions which is there in previously also. I was repeating so much of context here and there. Okay, you can just go through this document to get a better understanding on how RAG works along with the video recording what we are discussing right now. Okay, so our own application. So our application runs with the framework called LangChain. Okay, LangChain will simplify the LLM work. Means that this LangChain is like a kind of a Python library, you can assume. And inside that, there are a lot of pre-built functions. So those functions I can use and I can minimize my coding effort. Okay. So that's why we are calling LangChain as a LLM framework. We will discuss deeper about LangChain, Llama Index on tomorrow's class. LangChain and Llama Index only on tomorrow's class. See, Llama Index and LangChain. These two things we will be covering on tomorrow's class and the practical exercise. Okay. And then we will be using Facebook AI similarity search, that is FICE, for storing the vector embedding locally in the Google Colab file system itself. Here we will store. Okay. And then we have something called Hugging Face embeddings. Okay. Because we need an embedding model. See, we need an embedding model to do the RAG, right? Then only you can convert your word representation into a numerical representation, right? For that, we will be using a model called MPNet. Okay, MPNet is masked and permuted pre-training for language understanding. This model is a popular embedding model from Hugging Face. So this also we will be using for free. And then we will be running Olama inside this Google Colab itself. Okay, previously we were running Olama on my machine, right? We yesterday in class we saw Olama. So this Olama, what we did, it was running on my machine itself. Right? See, it's running on my machine itself. Same way, you can run this inside this Google Colab itself. Okay, for that we have something called Colab Exterm. This will give us the access to the terminal utility, that is command prompt inside this Google Colab itself. Okay, our aim is clear that we are not going to use any proprietary model, right? We are not going to use anything which we need to pay, right? For that particular purpose only, we have made a complex RAG application system like this. Okay. So here what we are going to do is, let me have my CD. Resume. I don't know where I put my resume. Let me take my resume first. So this is my resume. Okay. Let me download my resume. Okay. So now I have my resume here. Okay. So now my LLM, which is Llama 3.1, don't know anything about me, right? It don't know any information about me, right? So what I am trying to do is, I am trying to feed my CV for my RAG approach. Okay. What I am going to do is, I am going to feed my CV for my RAG approach, so that what will happen? So this document will be extracted, right? This document will be read with some PDF extractor, and this PDF extractor will convert this, will break these sentences, and those sentences will be converted into numerical representation, and that numerical representation will be stored in the vector database. And after that, if I am asking any question about my CV, what happens? It will simply convert that question into embedding, and that embedding will be run on this vector database using a similarity search or a Gaussian similarity or some other methods. There is something called BM25. Lot of methods are there. Based on some kind of methods, we are running it, and it will give us the relevant data. So that relevant data means that this is having the query, the question, along with the retrieved stuff. And this retrieved stuff, we will be passing back to Olama, and this Olama will generate me a proper response. So this is what we are going to build right now. Yeah, don't worry. We will extend this class for another 30 minutes also, but we need to understand what exactly. Yeah, Superior.
So this is like two-step process. First, we need to prepare our vector database and then start prompting that, right?
Yes, correct.
So say I am a user in my company itself. I am a user side, and I don't know whether vector database is having that information or not, because
Yes,
I just
correct.
prompt and it will
Correct.
not be having this one. So am I myself, I can do this RAG also, the feeding step as well, or I need to? So generally that maintained by multiple teams, right? I'm going to a
Uh,
real time example.
Data preparation alone can be done by data engineering. Okay, because that data might be in multiple sources. I don't know where and all I can find the data. As an AI engineer, if I go and ask a company, what I will do, I will simply talk to my data engineer and ask him to prepare all the data sources into a single data lake or a data warehouse.
So
Right?
it's a data source only. It is not vector database or vector.
Right, correct. When I
Data engineer. Okay.
data engineer will go up to their data lake only, data warehouse only. After that, data engineer won't go. From that point, AI engineer will need to take care of converting that data lake into a vector database.
Okay, so there will, for user, any user, if he don't find his relevant data, he will reach out to AI engineer, which
Yes,
means
correct, correct.
an AI guy.
Yes, correct.
Okay.
right? So this is how the ecosystem works inside the company, right? Your understanding is completely correct.
Okay.
Okay. So as I told, here we will be using LangChain. So for that, what I am going to do is I am going to install LangChain. So before running everything in Google Colab, what we need to do is we need to previously our runtime was CPU. We were using CPU, right? And we have a GPU also inside this Google Colab itself. Okay. I will change it to GPU. Why? Because I am going to run Olama inside my Google Colab itself, right? So means that I am going to run a server inside my Google Colab itself, right? For that particular purposes, I need a graphical processor. So for that, I am going to leverage the cloud GPU. This is completely free, right? I am not using any premium GPU. I am going to use only T4. T4 is completely free along with Google Colab. Okay. I need to change the runtime here. Like I need to click on here. I need to change the runtime type and I need to select this T4 GPU and click on save. Okay. Now connect it. Change limits. Sorry. Okay, let me connect it without GPU. Maybe a lot of people are connecting because this is a shared resource, right? I am not paying for it. Change it up. We need to connect to T4 again. Yeah, I think I used it already. It seems extensively. Okay. What I will do, I will simply share this notebook to my another account. I should check to my other Google profile. Yeah. Here I am using Google. Yeah, so this is my another account. Yeah, so here I am using this connect. It's connected now. See, now it got connected to T4. Yeah, so this is my GPU. This is my graphical processor. Okay, so there I am going to use this pip install command because I need LangChain, right? I told like LangChain is an LLM framework. This is going to simplify my AI development process. Okay, so now what I will do, I will simply install LangChain like this. Unlimited. Okay, now see, it's collecting all these things. We already see what is pip. We already saw what is pip, right? So what this pip did after executing, it just simply turned this to this one. So it got executed in 8 seconds. So within 8 seconds, what it did, it completely downloaded me the LangChain library, right? So LangChain package, it got downloaded. The same way I need something called LangChain community as well, because inside this, there are some other functions which I need to access. So for that, what I will do, I will be simply using this pip install command. You just need to execute this command. Okay, so what it will do, it will also install me the LangChain community as well, right? And I told you, like I am going to use this sentence transformers for what? For transforming this sentences into small chunks. So for that particular purpose, I am going to use this sentence transformers. This also I am installing. So what it will do, it will simply go and it will break the sentences, break the document into sentences. Okay. And then, as I told you, this is called as Facebook AI similarity search. This is FICE, right? So this is going to create, store, and process my vector databases. So for that, there are two packages. One is Spice CPU, and there is another package called Spice GPU. Okay. If we are installing this, then we can use the power of this Facebook's AI similarity search databases. This is a vector database stuff. So that also we are installing. Right. So it installed Spice GPU. And after that, I have a PyPDF. PyPDF is to process my PDF into a text. Because I am going to upload my resume here, right? For uploading my resume, I need to use this PyPDF package. So if I use this, what happens? It just again collects and it downloads and it installs the same pip work. So now we have installed all our packages. So now, as per our document, again I am explaining, we have three steps. One is data ingestion, another one is data retrieval, and the third one is data generation. So data ingestion means like we are going to use this PyPDF to first fetch the data and convert that into text. And that text with the sentence transformer, we are chunking it, right? And then using files, using our embedding models, that is from Hugging Face, that one will be converted that data into embeddings. And that converted embeddings using FIS, FAISS, that is Facebook AI similarity search, we will be storing it into our database. For our case, it will be a folder. Okay. After that, when a user prompts with something, okay, it will be also getting converted into embedding, right? So this one will be taken care by LangChain itself. And this one again will do a semantic search inside this vector database, and that will be sent to a ranked result, re-ranked result, right? So these and all are the internal process of FIS. So the semantic search, database, ranking, re-ranking, all these things will be taken care by FIS, Facebook AI similarity search. And after that, we will be getting some chunks of data, that chunks of embeddings. Along with that query embedding, we will be passing that query plus prompt plus context. We will be passing everything, that is the response from the database, and then the user query, and then the prompt. So these things and all we will augment here, and that augmented thing we will be passing to LLM, and that LLM will generate something that we will be again seeing that. Right. So this is what is the complete plan of our project right now. Okay, so this is the diagram. Okay. So here we have something called context window. Right, we saw Google Gemini was having some 2 million context window. Right, the same way Llama is also having some context window. Means that your query, right, your user query, along with your searched database output, those should be within that context window. Means that much token only your LLM can process as an input. Right. So that's what we are explaining here. So ChatGPT is having this much context window. So means that ChatGPT supports 8,192 tokens, not like 2 million tokens. How the previous Google Gemini was having. Okay, but anyway, we are not going to use ChatGPT. But Llama 3.1 also is similar to this number of tokens. Okay. Means that you can pass this as a simple input, single input like this. Maybe my entire resume will not exceed this. Okay. So now we have this LangChain stuffs, right? So I am going to import these functions from LangChain document loader. I am going to import this PyPDF loader, right? So this will be useful to load my PDF. Also, I have a character text splitter from LangChain. Okay. LangChain itself, there is an embeddings library. In that we are going to use this Hugging Face embeddings. So this is going to be my function. So these functions alone we are importing. Okay. We are importing vector store, that is for FIS. This is FIS support. Right. I'm not going to write each and everything inside this. So that I can simply import these functions and I can use it. So this is the ability these LLM frameworks are giving us, LangChain, Llama Index. Like this. Okay, and then I am using something called Retrieval QA. So this Retrieval QA will help me to create a chain with this question query and then the embedding to generate an answer like this. Okay. And then using Google Colab, inside this Google Colab itself, I am going to use the file uploader. So for that, I am using these files. Okay. So this one only
Out
we are
of
doing.
out of these packages, Sarul, like so generally in organization, maybe if I want to try it in my system,
Yeah.
because everything is open or any of them restricted kind of thing. So
No,
generally,
everything is open source only. Everything is from open source. All these packages are from LangChain. Right? LangChain is an open source LLM.
so organizations generally don't restrict these things.
No, don't
This is
restrict that. So
okay.
if your organization is allowing you to do a pip install, you can directly do that because we did a pip install only, right? So now these packages are in my machine.
Mhm.
Uh, just to add on, Arun, Sudhir, in our organization, we can't do that. From outside, we can't do that. Whatever is exist in the software center, right? Only those things you can type. If you want these imports, all these plugin, all these, you will get it from Artifactory. One Artifactory is there. In that,
Mhm.
all these modules, everything will be there. So you can download there. From Artifactory, you can download.
And
But
you
from
can put it on the site distribution packages. In that, yeah, if you put it in the site distribution packages directly by yourself, you can download, and if you are able to put that in the site distribution, right? When what it is happening when you are downloading a package, it goes to this one only, right? This distribution packages,
Mhm.
right? So you can directly go and put it in this distribution packages by unzipping that because these and all are .py files only mostly. So you can directly put that packages like that folder along with that .py file. So these and all are .py files. These are modules, right? So these things and all, these are modules, I guess. So this complete package, LangChain folder alone, you can put it in there so that you can directly access it like this.
Okay. Okay. The
If
reason
pip
I'm
is
asking,
bad.
I was trying to install pip install this CX Oracle to connect to the Oracle database, and
Okay.
that I was not able to install, saying some Visual Studio is mandatory, and that Visual Studio again is a restricted one like that. That's where like
That is running on VC++ distribution, I guess.
okay.
So yeah, VC++ distribution itself is a library and that needs Visual Studio. Likewise, only Microsoft products are like a bit complex stuff. So some of them needs a C++ distribution, that is Visual C++ distribution to run most of the things. Okay,
Okay.
likewise. Okay. So this is how you can do the imports in your organization. If it is restricting, then you can go directly download these packages and put it on this distribution packages, and you can use this download. Because whenever you are doing a pip install, it is simply putting everything into your distribution packages. See, right? It's putting everything into the distribution packages. Likewise, you can put it on the distribution packages and you can utilize that. Okay, that is also one way to use this.
Got it.
And then here we are using these files to do the file upload. So if I execute this, what happens? Again, it will let me to upload this file. This is a file uploader utility. This one also we saw in our classes. You remember? So that one, using this, I can upload my resume. So this is my downloaded resume. Okay. And double click this. What happens? Now my uploader took my resume and that resume name I am getting here, right? So this is the name of this, right? And my loader took this PDF, and now my loader is loaded with this likewise. So my documents, this text will contain my complete C, right? If I add a text, okay, like here. Now if I'm printing my documents, so this variable will contain my complete CV. See, it's having my entire metadata, right? So my complete CV is here as a text in this document. Okay, so this is a list. So inside that list, my complete document got loaded with this PyPDF loader. So now I can see this in my file system. See here it came in, right? So my document is here. Okay, and then what I'm trying to do is we will be using this character text splitter. Okay, to split this text into small chunks like this. Okay, now I am trying to do a chunk size of 1000. Okay, means that 1000 characters, it will put it into small. And after that, I am asking it to put a separator of /n. So that this will be my delimiter. Okay. See now first it took the first 1000 and then it is putting a /n. Likewise, it will split. Okay. So now I am splitting my documents using this. And then the next part is the embeddings. Right? We talked about embeddings. Embeddings means what? This will be completely converting your text format into vectors. Okay. For that, we are going to use this MPNet, that is Hugging Face embedding. MPNet is from masked and permuted pre-training for language understanding. This is an embedding model. So using this Hugging Face model, we are converting this entire text into embeddings. This is just for storing the information into vector database. This is a one-time process. Once it reaches your vector database, again and again, you won't do that. Okay. So these and all are from data engineering team to your vector database. So up to this point, travel only. So before putting that into a vector database, I need to convert my character text representation format into a numerical representation format, right? So now I can print this embedding as well. Okay, let's see what's happening. See, it's trying to access the Hugging Face, right? So now with that, it is trying to embed using Hugging Face libraries. Okay, so now it is printing me this one. Embedded tokens, it won't show. That we will see it later. Okay, I was trying to print, but it is not showing. Okay, so now my embedding process is done. After that, we are going to use this Facebook AI similarity search to store that into vector database. Okay, so now this is my face. Okay, this face, what it will do, it will convert this docs, that is my document, into embeddings like this. Loading the data and corresponding embedding into the face. So now I can print this like this. Store. See, my vector store is an object. That's why it is showing like that. Don't know like whether I can access this text or not. Vector store dot text or string I can convert. No, it will convert. I don't want to play with that. It is an object actually. Okay, so this object it will convert now. And now I am asking it to store it locally. Okay, this vector store that will be saved locally under this particular folder, this files index folder. Okay, see now if you see, there is a folder called face index got created, right? So this is Facebook AI similarity search. So this one created vectors. So that numerical representations looks like this. Okay, this is an encrypted numerical representation. See, like this it will show for you. So this is my complete C. Okay, and this is this CV, at least in a readable format, it will be looking like this. So this is the text format. Okay, and it is showing it is putting that in the embedded, transformed embedded numerical representation. Okay, that is getting stored as a file here. Okay, and I can load it from the local storage and I can see it here. Okay, on top of that, there is something called retriever. Okay, so this retriever, again, we will see it in deeper when we are studying about llama index. Llama index also, we will use these retrievers. So what it will do, this is going to serve as my key stuff for me. So using this retriever, I can simply search something from the vector store. Okay, so now my persistent vector store will have this everything, and then there is a retriever which we are building on top of this database. So this retriever is going to help me whenever I am passing anything inside this database to search. Okay, if I want to search anything, this retriever will be going to help me. Okay, and then now only our hero comes in. This is LangChain's Volama. Okay, this is not going to install everything about Volama. Again, we are going to install Volama. That also we will see. But this will be installing the LangChain support for Volama. Okay. So up to this point, up to this retriever building, okay, our embedding stuff's completed. That means that our up to this part is completed. This part, up to this part, it got completed. So after this, again and again, we are not going to do this. This is the one-time process to convert my company's data into a numerical representation and I store it here, right? So my company's data is nothing but my CV. So my CV, I chunked it and I convert that into embedding and that embeddings got stored. So for converting that into embedding, we were using some Hugging Face embeddings. Okay, that will simply convert this text representation into numerical representation. And those numerical representation, we stored it with the help of FAIS, FAISS. So now my FAIS will serve as my vector database. On top of that, we have built a retriever. So now my retriever is sitting here. Okay, so whenever I am getting a query, my retriever will go inside and it will search something and it will pass back. Okay, my retriever and my database is going to be used in future for accessing this. Okay, now the magic what we are going to do is, so up to this point we have executed. So now we have installed the Volama LangChain support for Volama. So LangChain is going to be my LLM framework. We will see brief about what is an LLM framework on tomorrow, right? Anyway, LangChain, Llama Index, those we are going to use when we are in need of writing big functions. So by that time, this will simplify our work. Okay, because this is having the support for all the LLMs, not only Volama, it have OpenAI support, it have Gemini API support, it has Claude support, all these supports are there. Everything is built on some modules. Those are like helper functions. Those helper functions are clubbed together and they made a framework. So that framework is called as LangChain and Llama Index like this. So here we install LangChain, Volama, right? So now we are going to install this collab extern. Collab extern is nothing but this is the terminal which we are going to use it for running the Volama. Okay. Now if I execute this cell, what happens? It's installing and it is loading this collab extern first. So now I can access the terminal inside my Google Colab itself. So the terminal means this terminal is my cloud terminal. Okay, see it's launching, right? Now see a black window will come. This is looking like our what? Our command prompt, right? So now I got my command prompt. Okay, so now I need to download and install Volama. Thus, Volama is the server which can serve my Llama 3.1 local language model. Okay, to install that server, you need to pass this command. For helping that purpose, I have put this command here. Okay, what I need to do is This is curl. This is simple Unix command. And then HTTPS. Then double slash Olama. This will be very slow only because we are running on the server, and inside that server we are accessing its terminal and we are playing. Okay, this will be very easier if I could have used OpenAI, but I don't want to use OpenAI because OpenAI is chargeable. So you can, if you don't want to use your credit cards and all these stuffs, right? And you don't want, if you don't want to use the publicly available stuff, right? So for that particular purpose only we are using this. Okay, so now what it is doing, it is installing Olama to my local. Okay, now it should download my Olama here. So one more thing you need to concern, up to your entire stuff, your terminal should not, like your runtime should not get terminated. This is actually fastly downloading just because, see now Olama is already available on this particular stuff inside Google Colabits. So now I can do like Olama set. So means that this will start the Olama set. Okay. See, now it started this Olama set. Right? And now I need to do Olama pull Llama 3.0. Just doing an interrupt. Okay, again I'm running my external. Sometimes it will stuck. Okay, by that time you can run again and again so that it will open a new command prompt here. So now you can use this Olama serve and Olama pull. Then it is not. Sometimes it will be dead slow also. See, now it is coming. Llama 3.1. So you need to be very patient when you are running. See, now it is trying to pull this Llama 3.1. Okay, so now I use this. This is just a package. Okay, let me try to initialize. Try to ask you a question. See, now it's executing, right? It's going here and it is trying to ask this question in the terminal. See, it's showing that Olama not found. Olama call failed because my model is not pulled actually. Yeah. Again, I need to install it. Olama, Olama. Llama 3.2. See, now only this model is getting downloaded. So this is a 4.7 GB model. Don't worry, anyway, we are running it in the server. It's running at the speed of 109 Mbps. Right, so it's trying to download this Llama model. So now my Llama 3.1, this entire model copy of Facebook, that is getting downloaded it into my local machine. Right, so this is like my local machine. So my local machine is running on this Google Colab, and that this Olama is helping me to run as a server and serve this model. Okay, so this is what we discussed on yesterday's class. Olama, LM Studio, and all this are right. Open source LLMs. So this is used to execute an LLM and bring that LLM for serving you like this. Okay, it takes some time. Okay, let's wait for some time. So after pulling Llama 3.1, again you need to bring up the server, Olama server. Then what happens? This will be this will be available in your machine to execute. Means that this model will be available for asking questions. Okay, so this is why we have, see now it is saying that the writing got success, right? So it just stored this, downloaded the model into my Google Colapse file system somewhere. Okay, if I do a Olamasa, see it's saying that address already in use, means that this is already executing. So I don't need to do a serve once again. So now if I am executing this, will import and I am setting this LLM model. And now I am asking a question to the LLM just to test whether it already knows about Arul Benjamin Sundar. Okay, because this is the detail which is present inside my C. Now I am executing this. It is trying to execute this question on top of Olama. Right. So up to this point, I am not doing any drag. So now what it is saying? It is saying that I cannot provide information on a private citizen. Is there anything else I can help you like this? Because it don't know any information about Arul Benjamin Chandra inside this model. Right? That's why it is saying like that. So now what I am going to do is I am going to use this llama along with my RAG. Okay. So for that particular purpose, what I will do, I will use this retrieval QA. So in this retrieval QA, what I am going to do is I am going to pass my retriever. Okay. So now my QA will hold my retriever. So this retriever we saw already. This was built on this FaceDB. We have generated a retriever here. So this one created a retriever. So inside that retriever, I can pass any query, right? So this inside this retriever, now my retriever will be set as a Q, set in the variable called QA. Inside my QA, I can run any query I want. Okay. So now what I am doing, I'm just prompting this as an input box, right? Anyway, I will be putting the same question now because this is there in my CV, right? This is my personal information. If I am directly asking it to LLM, LLM told that it cannot provide a certain response. See, now it is saying that according to the provided context, Arul Benjamin Chandri Binay is a senior analyst with over 11 years of experience in data engineering. And his email ID is this one, arulbenjaminchandru@gmail.com. Like this. So where this information is coming? It is coming from my resume. Okay. So I just put this in a while loop so I can ask whatever questions I want. So let's ask. See, I didn't include in my date of birth in my resume. That's why it is saying that the provided context does not include information about Arul Benjamin. So then I am asking, what is his mobile number? See, it is giving me my mobile number, right? My mobile number is there in my resume. Okay, where he studied. See, I studied at Madurai Kamaraj University. This is my educational background, right? All this information, it is taking it from my CV, right? What is his experience? It's again going in, and based on the provided context, I worked on these so and so companies on the past 11 years. Here is the breakdown of his experience. Right, I started my career as a mainframe developer and went into data engineering, legacy modernization, and a lot of stuff. And then now I am working as a data. Okay. So this is what is all about RAG, and you can utilize this RAG in your local machines also. If I type exit, this will break because this is a while loop and my query is having exit, it is break. Okay, this break statement, exit, everything is in the classes. So here what we did, we have built a complete RAG system, and my data was my CV, curriculum vitae, and we were chunking this using this transformers, sentence transformers, and with that, this LangChain support gave me the ability to access that sentence transformer easily, right? Again, I was doing Hugging Face models to embed this data, and that embedded data we stored in FAIS, that is FAISS. On top of this FAIS, we built a retriever. Again, this retriever will be useful with my LangChain to use this retrieval operations, right? And when user gives a query, that query also gets embedded and that got semantically searched in the database. Like when I was asking like what is my email ID or what is my experience, right? So that is getting converted it into embedding, and that embedding gets searched in this database, and that database got retrieved, and that retrieved information along with that user query, it went into Llama 3.1 that also we are serving it locally, right, in our external here. Right, see, this is running Llama 3.1, right? So this one will take care of generating my augmented text into a human readable format. Like it is not simply putting my resume information. Okay, it simply converts everything into a human readable form in some other person perspective. My resume, I usually write it my perspective, on my own perspective, right? I led, I worked, I gained, like I see, it transformed that into a human readable sentence, right? Likewise. So this is how the entire RAG system works. And this is one of the hottest cake in the market. Please let me know if you have any doubts, so that we can discuss that topic alone further. Otherwise, we can drop that. Hello, am I talking alone? No one is talking.
No, yeah, it's clear. So for for real time data, how we will push? So
Yeah,
like okay,
that's why Ravi. Like now we have used FIS, right? FAISS. That is for our representational purpose we used. Instead of that
okay,
FAISS, what companies will do, they will be having their own proprietary vector databases. Means that they have license to this PG vector, right?
okay,
PG vector is one vector database. So what they will do, they will use their data engineering team to convert that data into data lakes. And from that, AI engineers will convert that data with embeddings, and that embeddings will be stored on the PG vector. So in real time, whatever data lake you are having, that representation will be converted it into data vector. So all these things will be covered up in the data pipelines. Like
okay.
yeah. So there's any questions? Yeah, Ravi, yeah, please go ahead. Ask it.
Yeah, that's all. Arun. Let's try also because this is end to end project now. So we'll also try one sample one. Let's see.
Yeah, right, Ravi. Yeah. Please try it out. Like at least try to execute this Google Colab based on the instruction what we have discussed in this class. Because RAG is the very important approach for this complete generative AI, because this covers everything in generative AI. So this is the one which markets are using right now, and everywhere you are seeing that Accenture win this $3 billion deal or 20 billion, whatever it is, right? So they are going to convert everything using this RAG only. So RAG is the main thing in the generative AI. Okay, anyway, apart from GenAI engineers, machine learning engineers will take care of this fine tuning and all. Fine tuning also, I will give a brief on tomorrow, like how that is working. Okay, there are certain notebooks to take care of that. So that's the complete machine learning area. That's not generative AI, actually, fine tuning. Okay,
Okay.
so that will be taken care by the ML operations engineer, machine learning operations engineer. Okay. Hope this makes a clear picture on how RAG is working, and that is the whole purpose of this class. Yeah, any more doubts, Ravi, so that we can discuss
No,
or else?
no, Arul, we are good. Yeah. Thank you so much.
Yeah, thank you, Ravi. Srini, do you have any doubts?